Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the operation of the BJT, operating principles of BJT, where in the previous video we saw why the BJT is used and what are the construction, that is structure of BJT. Here we are going to see about the operation principles of BJT. As I told you already, we are going to specifically use the one major configuration types is that we have three different configurations here. One is common base, common emitter and common collector configuration. Three types, that is common base, common emitter and common collector. Whereas comparing to these three configurations, the common emitter is the best one, where we get an exact amplification output and a very high efficiency in it. Okay, in this diagram we can see that, as I told you already, the base is of smaller in size, and emitter comparatively comparing to the base, emitter will be of bit larger in size, and when comparing to emitter and base, collector will be of even more larger in size. Okay. See, we are going to talk about the common emitter, right, where the base and the collector is connected commonly to the emitter. This is called the common emitter configuration, where VBB is a base current which is given towards with the base, and an emitter is connected, and RC along with that is RB is a base resistance and RC is a collector resistance which is connected with VCC, collector current, along with this emitter. Okay, where the collector current flows through the collector and emitter current flows out from the emitter, whereas the IB, that is base current, flows into the base. Okay. Current flow, how does the current flows here? IE is equal to IC plus IB, where which is this emitter is very common, right, common to the base and the collector. So emitter current IC which flows in IE is equal to IC, that is collector current, plus IB, that is base current, where we get a total current of IE. Okay, biasing conditions, we have two biasing conditions, that is a base emitter and a base collector configuration. We are going to make it as forward bias in base emitter, and base collector we are going to make it as reverse bias. Okay, operation modes, how does it operate? As we all know that NPN is a transistor. Okay, it is a type of BJT transistor. N, which is specifically filled with the electrons, a P which is of holes, and N is also the electrons. Okay, once the supply is given, okay, the current flowing through the collector, where we have electrons over there, and in base we have, that is which is mentioned as P, where we'll have holes, and again in the N we'll have electrons. So electrons and holes recombination occurs. Okay, electron flow occurs when supply is given. Electron flow occurs inside the NPN transistor. Inside the NPN transistor, where the electrons and holes gets recombinated. Okay, and then when recombination occurs, okay, the electrons, the losing electrons, the energy losing electrons will form into a depletion region, and a electron flow from the emitter comes out, and the base current and the emitter current can be identified. Okay, the operation modes, how it is operated is that electron flow and then hole flow. According to the electrons and hole recombination flows, this operation can be identified. This is an characteristics of operating modes. Here we have three different categories of operating regions. Okay, that is as I told you already, we have three configurations, that is common emitter, common base and common collector configuration, which is specifically used, what we are going to use it, common emitter configuration. Whereas in all BJTs we have, specifically in BJT we have three operating regions, that is cutoff region, active region and saturation region. Okay, cutoff region is that the condition both junctions reverse bias. Okay, both the junction, that is J1 and J2, whereas it both is in a reverse bias condition where both the terminals, that is terminals that has been connected to the negative one. Okay, base and collector, when it is connected with the negative one, it will be acting as a cutoff region, which is a reverse bias, which is in a reverse bias condition. Whereas in active region, one end it will be connected to a negative part and another one it is connected to a positive part. So BE, that is base and emitter, will be in a forward condition. B and C, that is base and collector, will be in a reverse bias condition, where the current flows is equal to IC is equal to beta into IB. Okay, beta is a total gain occurred by the emitter collector common emitter configuration. Okay, next is saturation region. What is called saturation region is that both the junction is in a forward bias condition. Cutoff region is that both the region in a reverse bias condition, where we have both the terminals or will be connected to the negative. Active, one terminal will be of positive and other terminal will be of negative, so it will be acting as a very active one. And in the saturation region, both will be acting as a forward region, whereas both the terminals will be connected to the positive one. This transistor gets on, that is closed switch, the entire circuit will be in a off state, closed state. Okay, these are the working and operations of BJT, and the structure of BJT has been seen. Thank you.